So let's look at a word problem that uses quadratic functions. So these will come up when we have something that behaves in a quadratic way. But a big piece will be that the vertex can help us find a maximum or minimum. Now if it's concave down, it'll give a maximum. If it's concave up, it'll give us a minimum. Okay, so we have the study of the spread of malaria. So we're tracking P, which is the number of people who are infected, and then T, which is the number of days after the outbreak. So we have our function, and then we have this limit on our domain that we're only going to let T be more than or equal to 1. The idea that day 1 after the outbreak would be where we would start. Okay, so let's look at calculating some values and then practice interpreting those values into a full sentence. So, P of 7, so what we're doing is plugging in 7 for our variable T. So we're doing negative 1/4, 7 minus 14 squared plus 229. And with that, we can just take that to a calculator, plug it in all at once. So let's go to our Desmos calculator. So negative 1/4, and then in parentheses, 7 minus 14 squared, and then plus 229. So that's going to be 216.75. This is number of people. So let's go ahead and round this to a whole number. So this will be about 217. So this is 7 days after into the breakout or outbreak, and then we see about 217 people are infected. So let me write about 217 people are infected. After 7 days. Okay, solving P of T equals 85. So what we're going to do is plug in 85 for P of T and then solve for T. So with this, we're going to solve a quadratic. We're going to use that method that I showed with vertex form, where we're going to isolate this squared expression. So we're going to isolate that T minus 14 squared. So first thing I'm going to do is subtract 229 from both sides. And that should give a negative 144 equals negative 1/4 T minus 14 squared. There's two ways you can deal with this negative 1/4. You can either divide both sides by negative 1/4, or you can multiply by negative 4. If we do that, if we multiply by negative 4, so the negative times negative turns positive, and then those denominators end up canceling out. So we could just multiply both sides by negative 4, and that should give us a positive 576 equals T minus 14 squared. Then we're going to take the square root of both sides. So we can get rid of that exponent of 2. So when we do that, we're going to end up with T minus 14 outside of the parentheses without an exponent anymore because the root and the exponent cancel out, equals, now because we took the square root of both sides, we have plus or minus, and then the square root of 576, which I'm sure we can use our calculator to help us out. We have our square root, 576 is 24. So we have a plus or minus 24. Then I'm going to add 14 to both sides. So what we get for this is T equals 14 plus or minus 24, which gives us two solutions. We have the subtraction, so 14 minus 24, which is negative 10, or 14 plus 24, which would be 38. Now the negative 10 doesn't work for us. That's outside of our domain, so we are not going to look at that answer, but instead we'll just have this t equals 38. So 38 days into the outbreak, we have 85 people are infected. So 85 people are infected after 38 days. Okay, similar example here, but we're just plugging in 0 for p. So we'll have 0 equals negative 1/4 t minus 14 squared plus 229. And we're going to go through the same exact routine as we did up above there. Subtract 229 from both sides. So we'll have negative 229 equals negative 1/4 t minus 14 squared. You can do that multiplication of negative 4, or you could divide by negative 1/4. Either way, then multiply by negative 4, multiply by negative 4. We're going to end up with 916 equals t minus 14 squared. Now I'm going to take the square root to get rid of that exponent of 2, and this will give us our plus or minus. So I'm going to have t minus 14 equals plus or minus, and then that's square root of 916. Now if we go to our calculator, plug in 916, see we're getting kind of a messy number out. I recommend that you don't round until the very end of questions. If we round too early and then keep using that number, it can add a lot of error to the answer, especially depending on what type of functions we're using. This particular example wouldn't be too bad if we rounded right now, but just to kind of establish the habit of it, as soon as I see that decimal, I'm going to leave it as square root of 916 for as long as I can. So what I'm going to do is write it as plus or minus square root of 916. Just for now. Eventually I'll get to a decimal answer, but while I still have some math to do, like adding 14 to both sides, then when I get here, t equals 14 plus or minus square root of 916. Now I'm going to go to the calculator and get those decimal answers out. So looking at the subtraction between the two numbers, so 14 minus, I can see that negative 16 point. I'll go ahead and round this to 2 decimal places, so that's going to be a 0.27. So I'll go ahead and write that down, negative 16.27. And then I want to look at the addition of the two. This is where I love this calculator because you can just click and edit right there. You don't have to retype everything. 44.27. All right. So according to our domain, we shouldn't be having numbers less than 1 showing up. So we won't use that negative 16.27, but we will use that 44.27. Now this is number of days. You can leave it as 44.27, but if you want to round it like to about 44, that would be fine too. So for this one, we have 44 days, and then our number of people is 0. So the number of people that are infected is 0 after 44 days. So I'm going to say there will no longer be anyone infected. After about 44 days. Alright, vertex of the function. Well, our function's in vertex form, so we can see we have this 14 coming through. Again, you're just using the number right here. We expect that subtraction to be there, or if it helps to think of it like you see minus 14, so in the vertex it'll be positive 14. Kind of switches how it looks. And then y stays exactly the same, so positive 229, positive 229. So that'll be our vertex, so 14 229. And then I'm just going to take a look at what shape we have for our parabola. So this negative 1/4, that's our value for A. So A is negative 1/4, which means we have something that looks concave down. So because A is negative, we'd have something concave down. So when we're looking at this vertex, and we have our general shape, even without any real points plotted, our vertex is representing this maximum value that's coming out. We're getting our number of days t, and it's this maximum value for p. So the number of people, so it's like the maximum number of people that will be infected. So the idea is that it was growing, so there was the outbreak, and the number of people infected grew and grew, and then at some point they're going to start vaccinating and helping people get better, and then the number of people infected will decrease from there until it hits 0. So this is representing the maximum number of infected. So we have the number of days when we expect that to happen and the number of people. So I'm going to say something like after 14 days, the maximum number of people infected will be 229. All right, so that's some ways we can work with our quadratic functions in a word problem and using Desmos calculator as a support.